What about this one? We have a blown fuse as well. So both fuses are blown. Here we have a PS5 that came in for a ripped disk drive connector. But that's not the only problem. The customer attempted the repair, and I think he thought he was carving the Mona Lisa. Let me show you what's going on. The customer tried to grind the traces so he can resolder the connector, and that's what he did. He went in so deep that he exposed the ground layer on all traces. Right now, the only way to work with this is to cover all that ground that you see here. Let me grab my multimeter quick. If we measure ground to here, we have ground on all the pins right now because of all the grinding that happened on this board. What can you do? We do see a pad here that should go on this pad. We do see one here that should go right here. You know what? I do have a donor PS5 board. Yeah, right there. I do have a donor board right next to me. Right here. And maybe we can measure this connector just to figure out the pin layout where each pin goes. So if we measure in diode mode, if we measure here, we know that this pin is not ground, and we know that this pin should connect with this pad. And if we measure here, we know that this pin is not ground, 0.4 voltage drop, and this pin should connect here. What about the center pins? I cannot tell unless we remove the connector and see if we have any vias, but let's measure. Oh, it looks like this pin is ground. And we have ground here. So maybe both pins in the center are ground. If that's the case, then we should have no problem, because we do have a piece of this pad left on the board. We do have a piece of that pad left on the board, and those we can connect to ground, and the job is done. But I do not know if we are supposed to have low resistance on those pins or if they are supposed to be connected to ground. Let me go to resistance mode, and we're gonna measure right here. What do we have? We have a that short here, so that's most likely ground. And here we have a that short here also, so that's ground. We're gonna assume that both of those are ground. I'm reading on one of them exactly 0 ohms, and on the other one I'm reading 0.1 ohms. But that's the margin of error of the meter, the tolerance. So 0.1 should be considered ground. What we can do to be sure is we can remove the connector and see if we have any vias under the connector. We can do that fairly quick. Let's apply some flux. Now the customer did mail over the connector with the console, so we do not need to use our connector. Maybe we can use it for somebody else, even though we have a lot of donor PS5 boards, so we're never gonna run out of connectors. But to safely remove this connector, we're gonna apply low melt solder, fume extractor on. We can remove the connector without applying any hot air. The magic of low melt solder. Done. And I just want to see if those traces, they connect to any vias, and they do not. They go straight to ground. That's what I wanted to know. Let's go back to the customer's board right here. Now for those two, it's okay to have ground here. We're gonna solder the pins directly onto those ground layer. Ground, that's okay. But we're gonna have to cover this. We're gonna have to cover this, this, and this. Then we're gonna grind here and run wires from here to the pin, here to the pin. And we're gonna have a better than factory job. Just clean any residue of dust, debris. So when we apply the solder mask, it holds, it grabs. And today we're gonna be using the green mask. We sell those solder masks in many colors, but right now I think we only have I believe red and green. They all do the same job. It's just a matter of color preference. And I'm just gonna take a little bit off from the tip on a blade. Do not squeeze solder mask like this. That's not the way you use solder mask. Just scrape with the blade, and we have enough to cover the exposed layer, the exposed ground layer. And then with the tweezer, with the tip of the tweezer, we just take a little bit and we go like this. We're gonna hide this. Actually, we need a lot because we need to cover this whole area. It's not a lot, but we need to spread that mask. Now we do not really need to mask the others because they all connect to ground. We can do it later. But for now, what we need to do is UV light along with hot air. Hot air helps with the curing of UV mask. Instead of taking 2 minutes to cure, it takes 10 seconds to cure. I went over hot air and UV in a previous video where I shared that secret. It's really considered a secret because nobody knows about it. Unless you're a chemist. You see, I'm applying hot air and UV. You see how that UV mask cured fast? And all the tools I'm using in this video can be purchased directly off our site. The grinding pen, original 559 Amtech Flux, low melt solder. You can get your soldering stations, hot air stations, tweezers, everything. Whatever you need, just log into our site, add to cart, check out, pay. All items are in stock and we almost always ship out same day. Our microscopes are currently out of stock, but we are expecting a shipment by probably January 10. Awesome. That's trace number 1. And let's do the other one. And to all the experts and scientists out there who watch the videos, and some of them, they comment, oh, that was easy, can you do something hard? We work on whatever customers mail over. The easier the better. We do not ask for hard. If something is gonna waste a lot of our time, we skip. That's how we are successful. That's how we have a multi-million-dollar business. Because we avoid wasting time. Time is more expensive than money. The time that you will lose, you will never get back. Money comes and goes. But people do not think about this. Every second that you waste out of your time, you're one step closer to death. Every second. Time is more expensive than money. If something is gonna waste my time, and I'm doing it for the sake of showing off, oh, look at me, I was able to do this or do that, but it took me 3 days. No, this is a business. If something is practical, we work on it. If it's not practical, we do not work on it. Oh, but somebody else can do it. That's fine, by all means. Let them work on it, but we are a business. We do not work on non-practical repairs. We do not work on repairs that will take hours and hours or days to fix. You can look at all the videos that we do every day. Usually repairs take about 5-10 minutes. Just like the iPad I posted yesterday. How long did it take? It took 5 minutes. How much are you going to charge the customer? We're going to charge them full price. Why? We're actually going to charge them more, because the faster we do it, the more we charge. We got the item back to the customer faster. So that's the way you can look at it. You did that repair in 1 minute. Are you going to charge full price? No, we're going to charge more, because we got it done faster. If you are locked out of your house in a rainy day and you call a locksmith and you get somebody telling you it's going to take me 5 hours to unlock that door, and another one tells you it's going to take me 30 seconds, but I charge more. Are you going to stay outside in the rain for 5 hours so you can pay less, or are you going to pay more and get it done faster? Makes sense, right? We have ground here, we have ground here. We do not have ground here, and we do not have ground here. Perfect. I'm gonna hand this over to Big Boss to reassemble and test, and I'll be back to finish the video. Okay, so I just got the board back from Big Boss, and he said it's not working. The disk drive is not spinning, it's not taking the disk in, and it looks like the connector is not receiving any voltage. Now what I did when he gave me the board was I removed the wire from here. I just wanted to check on this point, and it looks like we do not have any diode reading in this area. Look at this. And if we go to resistance mode, we're gonna probably get a very high reading. Actually, I'm getting OL. So it means the connection is broken. The connection is broken from where? It's broken from the back, because this point is connecting with back of the board. So we have to figure it out. You see, we're not getting any reading. And if we measure here in resistance mode, we have a reading of 2.3 mega ohms. So we are getting a reading here, but here, nothing. Oh well. Let me grab the donor board, and let's see what readings we get on the donor board. If we read in ohms mode right here, 217 ohms, and it's going down. We do have a reading. And if we read here, we are reading OL. The connector is here. We're gonna flip the board right here. So I do see some components on back of the board in this area. Look at this. We do have two fuses here. Let me read this one quick. And the fuse is blown. You see? What about this one? We have a blown fuse as well. So both fuses are blown. If we check the donor board right here, let's measure those components. And look at this. Those components are good. So we have two blown fuses on the customer's board. Let's remove them. Okay, so remove this one. We're gonna remove this one. Fume extractor on. Now we're gonna flip the board and measure again, and we're gonna have to fix that trace, that wire that we removed. But first, before we do anything, we need to measure and have a reading here. Before we were getting OL right here. Let's go to diode mode, and if we measure here, perfect. We are reading 0.46, and that's amazing. Before we were getting OL. So that was the problem. Very nice. And now we can cut that wire. We're gonna measure again, make sure we have a diode reading. And we're gonna measure at the pin. Perfect. Perfect. We do not need to mask any further. Everything is good. So hopefully this time it works, and I'll be back. All right, the boss of all bosses is done with the reassembly, because he had to remove the motherboard. And will the CD go in? That's a Windows CD. Yes, yes. So that means the drive is receiving power, and that's why the CD went in. Eject. Perfect. Perfect. Thank you, Big Boss. Welcome. The boss of all bosses. I hope you enjoyed the video. Let me know what you think. Leave it down in the comments. Don't forget to like and subscribe. And we'll do something else in the next video. And my dad is doing the packaging. We have one here. We have one here. We have one here. One here. One here. And a lot of priority envelopes and box. You have a lot?